My name is Muhammad Hakim bin Arisham. My number ID is 5122223175. Okay, this is my coding project. This Verilog code defines a module named counter that implements a 4-bit up and down counter. The module has 3 input signals and 1 output signal. Okay, the clock input controls when the counter updates its value. The reset input reset is used to clear the counter value to 0. The direction input direction determines whether the counter increments or decrements. The output counter out is a 4-bit register that stores the current count value, allowing the counter to represent numbers from 0 to 15. Always block sequential logic. The always or possess clock or possess reset block indicates that this is a sequential circuit. The logic inside this block executes whenever there is a rising edge of the clock or a rising edge of the reset signal, because the reset signal is included in the sensitivity list. The reset operation is asynchronous, meaning the counter can be reset immediately without waiting for a clock edge. Reset operation. When the reset signal is high, the counter output is set to 0. This condition has the highest priority in the always block, ensuring that the counter is cleared immediately whenever reset is activated. The counter value is assigned using a non-blocking assignment, which is the correct method for sequential logic implemented using flip-flops. Normal operation. When the reset signal is low, the counter operates normally. In this state, the counter updates its value only on the rising edge of the clock. The direction input is then checked to decide whether the counter should count up or count down. Count up operation. If the direction input is set to logic 0, the counter operates in the count up mode. In this mode, the counter increases its value by 1 on each rising edge of the clock. For example, the counter changed from 0001 to 0010 and then to 0011 with each clock pulse. Countdown operation. If the direction input is set to logic 1, the counter operates in the countdown mode. In this mode, the counter decreases its value by 1 on each rising edge of the clock. For example, the counter changed from 0100 to 0011 and then to 0010 as the clock continues. Overflow and underflow behavior. It has limited counting range from 0 to 15. When counting up, if the counter reaches 15 and receives another clock pulse, it overflows and wraps around back to 0. Similarly, when counting down, if the counter reaches 0 and receives another clock pulse, it underflows and wraps around to 15. This wrap around behavior is a natural property of binary counters. Use of non-blocking assignment. Non-blocking assignment are used in this design because the counter is sequential circuit. This ensures that all register updates occur simultaneously at the clock edge, preventing timing conflicts and making the behavior predictable during synthesis and simulation. Hardware implementation. In hardware, this Verilog code will be synthesized into 4 flip-flops along with combinational logic that controls the increment and decrement operations. The clock synchronizes all flip-flops, while the reset and direction inputs control the behavior of the counter. Overall summary. In summary, this design implements a 4-bit up bit up and down counter with is a synchronous reset. The counter updates its value on the rising edge of the clock, and the direction input controls whether the counter increments or decrements. This type of counter is commonly used in digital systems such as timers, controllers, and even counting applications. That's all from me. Thank you.